Alright, okay, so I previously did record sort of an introduction session that just explained sort of what we're going to be doing, but considering that the downloads took forever, I think I'm just going to leave it at, give it 1 second, I'm going to go close the door. I think I'm just going to leave it at, I'll reiterate everything I said before. Basically, what I had mentioned was that the format was changing. Now, you do not actually need to download everything on the school computers or your own computers. You could, which is why I'm making this video for anyone online who might want to get involved in what's happening. This is just going to be sort of a step-by-step process as to exactly what I've done, but you don't exactly need to follow this. This is more of just, for anyone who wants to take that extra initiative to actually get this done, or for anyone who did not really learn anything throughout those video lessons, who actually wants to learn and make sure that they're solid with everything that I had taught. So in terms of what you need to download, you're going to go to this WebPylib suite, all WebPylib releases. The link, I think you can search it up, or it's going to be right here. I might add it to the video description. If you just scroll down, you're going to see that this is the pre-release, so we're not going to be using the beta version because it's not fully released yet. So we're actually going to go to the latest actual release, and you'll see that there's this latest sign. It's going to be WebPylib 2021.3.1, and then you just download the version that matches with your operating system. So I did Windows 64-bit, so Windows 64 over here. And you're also going to go to Cross the Road Electronics Phoenix releases, and you're going to download whatever Phoenix framework installer you need. The .exe has some software, which is why it's so big. It's 109. It has the Phoenix tuner, amongst other things. You don't actually need that. I would suggest you just stick with the macOS zip because it's very small and it has everything you need to program the file. So I suggest you download that. I do have everything downloaded here. This is my little brother's laptop, so there might be a few things that I'm unsure about how to do, but it's basically Windows, so it shouldn't be that hard. So what you're going to do here is you're going to open up your .iso file. So I'm going to say I'm going to use Windows Explorer for this, and it should open the ISO file here. Okay, perfect. So I should see this WebPylib installer application file. So it should have this logo. It should say WebPylib installer, whatever, 66.858 kilobytes. It should be this one. It should be a .exe file. So I'm going to open this up, and that's going to install WebPylib for me and everything else I need from WebPylib. So this should show the screen with 2021.3.1 start. And I'm going to do for single install. So then it's going to do it for the current platform in a single install. And then once that bar finishes, I should be ready to go along with my downloads. And I also downloaded the macOS zip file, so I'm going to extract that into my folder. Okay, no, I refuse. So this is going to be in my downloads folder, so I'll just keep that there. Okay, perfect. So now I will actually just head in and make sure that it's still there in my downloads folder. Okay, perfect, it is. So yeah, now I'm just going to open this folder up, and so this should have all the files that I'm going to need later on, but I don't need that right now. So it says done downloading, next to continue. I'm going to go next. I need all of this. Technically, I don't need the C++ compiler, but I do suggest it, and I'm going to click install for this user. So even on your sort of thing, I suggest for this user because you do not need admin for that. Now we're just going to let this install. It's going to be a relatively long process. In the meantime, I'll just talk through sort of an explanation for the online members about what we've gone through or what we're going to be doing as a team. So as a programming team, we do need to program, the robot, amongst other things. And so in terms of programming the robot, there are many different parts to it. And so when we think about how a robot works, we can sort of think about it in a way of C sub or WebPylib subsystem. I think it's a good way of sort of explaining. So this is how we break down a robot. So when we think about subsystems, that's basically how we're going to be breaking down the different behaviors of the robot. And so this is where there's a nice little thing for this. I think it's in the robot builder section. This probably makes more sense. I'm going to find the exact sort of page where it explains. Okay, let's open up command prompt because it's downloading or configuring the tool, so it needs to do that. It's going to open up a few of them apparently. So robot builder, I'm just going to head into the introduction, the overview. Okay, so when we have a robot, so you'll see this robot over here, it's very easy to, or you should be able to split the robot into its different parts or its different sections that do different behaviors. So if you think about your own human body, you can split it up into, you have your limbs, so your arms and your legs that move around, you have and then within your limbs you have the fingers that, like you use to, you also move around and they do different behaviors. On your face, you have all these different senses, and I guess you could consider them to be sensors. So that's one sort of subsystem of your body. You have your limbs, another subsystem. You have your nervous system, right? So that's a subsystem. It pumps blood. The main purpose is to pump blood. You have our digestive system. Main purpose is to digest your food. On the robot, you have some sort of systems like that. So in this example over here, we have, this camera. So that's sort of the face where all the senses are coming in. You have a gripper that holds these tubes. So that's one subsystem. You can think of it sort of like as your hand. You have this lift over here, which moves it up, and that's another subsystem because it does a whole other behavior, sort of like your legs. And then back here we have like a scoring device or an alignment device. That's a whole other subsystem as well. So we sort of split the robot into different parts, and that's how we separate it into subsystems, and we'll be working with that as well. Okay, perfect. So this is finished installing. What's going to happen is it's going to tell me to open WebPilot from here. So I'll do that. Oh, thank you, OBS. So I'm going to click Open WebPilot VS Code, the 2021 WebPilot VS Code, and it should open up this screen over here. Perfect. This is sort of exactly what I want. And so from here, we're going to open up that robot builder software. So to open up anything or using the WebPilot extension, you're going to do Control-Shift-P, Control-Shift-P, and then you're going to type in your arrow. So you need that arrow at the beginning. It automatically adds it, but in case it's not there, you're going to add that arrow in, and then you're going to type in WebPilot like this, and then Start Tool. So WebPilot : space Start Tool. And then after you open up Start Tool, it'll have all these options, and you're going to click Robot Builder over here. And so once you click Robot Builder, give it a second, it should load this screen, the same screen as before, alongside the Robot Builder software. Where did that go? That went somewhere. Here. So this is going to be the new project settings where we add in the new project settings. So I'm just going to call this test for now because I actually don't need to create this project. So say create the project, but I'm going to delete it instantly so it doesn't actually save anything. And so now that I open up WebPilot, I actually need to install my extensions into WebPilot. And so to install the extensions, the Robot Builder extensions over here, what I'm going to do is I'm going to open up the Robot Builder folder. And to open up the folder, there are many different ways of doing it, but the way that I like to do it is you're going to open a new File Explorer window over here, right? Once you've opened up a new File Explorer window, you're going to go to this PC. You're going to go to your C drive, wherever that is, and then you're going to head down to your users, and then it's going to be in whatever user you have. So this one is Blot because it's named after my email. Don't worry about it. So you're going to head up into Blot, and then you should see whatever your sort of main folder is, and you're going to look for that WebPilib window. And if you don't see it, head down here and go to Public, and in your Public you should see this WebPilib folder over here. So it should say WebPilib in all lowercase. You're going to click into it. Go to 2021 because that's the year that we downloaded, and we're going to go to this Robot Builder folder over here. Once you're in this folder, you're going to click Open the Extensions folder, and you should see that it's empty. And then you're going to open up the zip file. So remember, this is the zip file that we extracted, the macOS one. You're going to go to this Robot Builder folder, and you're going to drag all of these folders into here. And you should see that it drags in. Perfect. Okay, now we've installed our Robot Builder extensions. So we're going to restart or reopen our WebPilib. So you're going to go to Recently Used Start Tool, press Enter, and then you should be able to open up Robot Builder again. And then once you open up Robot Builder, now we're actually going to make our robot. So I'm going to call this one our practice bot. So our practice bot is a very simple robot. All it has is 4 wheels, or four motors, and the wheels. So you have 2 motors on the left and 2 motors on the right, and you have the wheels on the bottom. So we're going to set our name to practice bot. You can set it with a C or an S depending on how you spell it. I spell it like this. And then you're going to do a 3560 here as well, because our team number is 3560. Whoop whoop, represent. So now we're going to click Create Project, and you should see the screen pop up. Okay, perfect. So now I'm going to full screen this. And so this is going to be all the information of our robot. So the autonomous command, autonomous is basically code that runs without user input. So this autonomous command is going to run without us touching the controller. So the robot runs by itself for 15 seconds. And that's where most of our coding knowledge comes into play. But we're not going to worry about that right now. We have our team number set correctly. We have our team robot name set correctly. Use default Java package exactly. Yep. We're going to change that up, I think. And then for this, we're going to change where project is exported. I personally like it in the documents folder, so I'm going to keep it there. And I'm going to make a new folder here, and I'm going to call this robotics, just because this is my little brother's computer, so he doesn't actually have this. But once this folder is selected, I'm going to click select folder over here, Okay, perfect. So now it's going to output there. Export subsystems, export commands, perfect, perfect, perfect. Okay, so now that I have all of this set up, I'm just going to minimize this tab onto the side because I don't need all of it right now. This is sort of where we wire up the different parts of our robot. So remember back when I was talking about subsystems and how we split our robot into different functions? Well, we only have one subsystem on our practice robot, and that's going to be the drive subsystem. So what we're going to be doing is we're basically going to head down to the subsystems menu over here, and we're going to drag this in. And so once you drag it in over here, we're going to change the name. So this is going to be our first subsystem, and we're going to change the name to whatever we need to change it to. So I currently think that the drive subsystem is a great name for this. So we're going to call this our drive subsystem over here. Perfect. So now that we have a drive subsystem set up, we'll see that there's an option for constants over here, and so these are any constants that we want to change within the code. So let's say that there's a constant for something very simple, like, constant for what USB port my mouse is plugged into. Well, if I change a USB port and I mention that USB port number, let's say it's port number 2 many times in my code, then I need to change that port number 2 multiple times. So to fix that, we use a constant, because if we set the constant, then we only have to change it once. But we're going to set the constant within our code, so I'm not actually going to deal with that right now. What I'm going to do is I'm just going to make my drive subsystem. And so in our drive subsystem, what we're going to do next is we're going to add our differential drive. And so differential drive is basically like tank drive. So you have two sets, right? And so one set is going to be on the left and one set is going to be on the right. So I can control the speed of the left one. So I can set it to go forward or backwards, and I can control the speed of the right one. So to make it go forward, the left and the right will go forward at the same speed. And that'll allow my robot to go forward. To make it go backward, they'll go, left and right will both go backwards at the same speed. If I want to turn to the left, then the right is going to turn a little bit faster. So when the right turns a little bit faster, it's going to veer to the left. And if I want to turn right, I'm going to make the left go a little bit faster, so it veers to the right, and so on and so forth. So that's basically tank drive or differential drive. And so we're going to get that drive system in our code. And so we're going to change this to we're just going to call it our drive over here, because that's just our drive. And you'll see that there's an option for maximum output, which we're not going to worry with. Safety, we should enable, and safety expiration time. And we're just going to set our left and our right motors as well, because we need those, which is why it's red right now. And so to set those, we're going to get a speed control group. And so a speed control group is exactly what it says here. It's a controller for combining multiple speed controllers. So we have two motors, right? And every single motor will be connected to a speed controller, because we want to control the speed of every single motor. And so those motor controllers are called speed controllers. And so we're going to get a speed controller group for the left and a speed controller group for the right. So we're going to call this one our left group, left over here. And we're going to make a new one for our right as well. So we're going to call this one our right. Alright, perfect. So now that we have our left and right speed controller groups, you should go to the actuator section and you should see 9 options here. If you don't see 9 options, that means you didn't install the extensions correctly. Remember, when you do install the extensions, you want to make sure you restart your robot builder, because that'll load up the extensions. We're going to actually drag in the Talon SRX. So that's going to be the 8th option, or the option with these heat sinks on the image. Notice how this one does not have a heatsink, it has more of a cross. We're going to get the one with the heat sinks on it. So we're going to drag one of these into our left over here, and we're going to call this our left front motor, so our left front speed controller. And we're going to do another one for our left back or left rear, depending on whatever you want to call it. I'll call it rear, just because, I don't know, that's what I like to use, that's my terminology. And I'm going to do the same over here. You'll notice that these things are still red, so we're going to have to patch that up. But let's just get in all of our parts first. So this robot builder is just to specify what parts are going to be inside of our robot so that it generates the code for us, which is exactly what we want. So we're going to make this our right rear and our right forward. Okay, perfect. So now we're going to click on my left sort of speed controller group, and I'm going to set my speed controller 1 to left front and my speed controller 2 to left rear. And that should fix itself. And I'm going to set my speed controller 1 to right front and my speed controller 2 to right rear for the right one as well. And now for drive, I'm going to do the same thing for this. So my left motor is going to be left and my right motor is going to be right. So now I have basically created my entire drive system over here, which is exactly what I wanted. And that's basically, all of the parts on our robot. We'll add the operator interface part ourselves, but everything else is exactly what we wanted on our robot. So we've done basically about everything that I've gone into in terms of what we did in class, but I'll actually go that little extra mile and we're going to write up the code. So this is going to be quite exciting, actually. It might be a little bit of a longer recording, but I'm going to try to keep it short. So once you've generated this, you're going to click this verify. And so once it says that your robot is valid, which we want to make sure it is valid because our robots need to be validated too, and ready to export, we're going to export our code. So to export it, you're going to click Java over here. And it should export to your export directory. And so our export directory, remember we set it over here, is going to be in my documents folder in robotics. So to open it up, I'm going to open up VS Code over here, and I'm going to do File, Open Folder, and then I'm going to go down to my documents, and I'm going to go down to robotics, and I'm going to click Practice Bot over here and select Folder. Okay, perfect. You should see all this fancy code over here alongside a WebPilot help window. None of which we really need right now. We're just going to be modifying the code. So I'm going to be full screening this window because this is where we'll be working from now on. So all of our code, you'll see this executing on the bottom. Don't worry about it for now. All this code on the bottom, we're just going to disregard it for now. We're going to be reading our code on the side over here. So we're going to click source because all of our code is going to be in source, and it should say main. And then we're going to go to Java. So all of our code is going to be inside of Java. And you should see our stuff on the inside of here. But before we get into that, we need to install our extension for our VS Code as well. And so to install our extension, you're going to open up this vendor deps folder over here. And this is going to be vendor dependencies. And so we have these dependencies because of all of the different sort of motor controllers, the speed controllers we're getting from CTRE, or Cross the Road Electronics. And so over here, you'll see that there's a vendor deps folder as well. Perfect. So we're going to open up the vendor deps folder, and you'll see this Phoenix JSON file, phoenix.json, and I'm going to drag that into this vendor deps folder over here. So you should copy into it. Okay, perfect. So once it's been copied, it should open it, but you don't actually need to read any of this. You're going to close it. But now we've sort of added our vendor dependency into our code. So what you're going to do is you're going to confirm this, and to confirm it, you're going to do Control-Shift-P, and you're going to do WebPilot. So you're going to type in WebPilot. Manage, so with the colon, vendor libraries. Okay, perfect. So we're going to do managed current libraries, and you should see that our CTRE Phoenix is right there and it's installed. So we're just going to press OK because we're good to go for now. Or I think we're good to go, which is perfect. So now we're going to modify our code actually. And so to modify our code, we're going to go down to our subsystems code, and you should see our drive subsystem.java. And it'll have all of our pre-formatted code and everything else that we need, which is pretty cool actually. And so now what we're going to do is it has generated all of our code and all of our sort of thing, but it's formatted very weirdly. And to format it properly, what I'm going to do is I'm going to do Control-Shift-P, and then I'm going to do Format Document. So it's also Shift-Alt-F, but you know, this is just a little bit easier. So I'm going to do Format Document, and now it should format my code and add the tabbing and look all pretty. Perfect. So now I have my drive subsystem completely set up and everything is good to go. So now what we're going to do is we're going to set a tank drive command. And so this tank drive command is basically going to be, or we're going to make a function for it, and then we're going to make our tank drive command as well. So put methods for controlling the subsystem here. So we're going to add our code in over here. And this is going to be sort of where I remind you that Java is relatively important, but it's not that important, so don't worry about it. What we're going to do is we're going to make a public method, and we're going to make it a void. So we're not trying to return anything. Remember, void means we're not returning anything. And so we're going to call this set left. And so what this method will do is it's going to set the speed of our left side. And then where our parameter is going to be speed. So this is going to be the speed at which we're at. And so speed in robot code is going to be anywhere between -1 to +1. And so for anyone who's worked with percents before, in their life knows that a percent or 100% is basically the same thing as 1. And so the same way over here, -1 is the same thing as -100%. So it's moving backwards at 100% speed. And 1 is the same thing as 100%. So it's moving forward at 100% speed. In the same sort of logic, 0.75 means I'm moving forward at 75% full speed. If I have -0.45, that means I am -0.45. That means I'm moving backwards at 45% speed. Right? And so that's sort of the logic of how speed works within our code. And so what we're going to do is we're going to set the speed and we're going to send it to our left speed controller group. So we know that our left speed controller group is called left. So I'll do left dot set, and when we do left dot set, we can set the speed of it. So we're going to set the speed to our speed over here. Perfect. And so once we set our speed, we're actually going to update the robot, and we're going to tell the robot, okay, we've set the speed. And so to update the robot, we're going to do left dot feed over here. And that should feed our information to the robot, I think. What? What do you mean feed is undefined? Does it automatically feed the thing now? I'm sure it doesn't. This used to be such a pain in the butt when I had to do it. Okay, I guess you don't actually need to do that. Pretty cool, I guess. They actually updated stuff. That's really nice. Maybe it's drive.feed. Okay, yeah. Drive does need to be fed. Okay, we'll do drive.feed over here. So that's to update the drive and tell it that we did actually do something. And we're going to do the same thing for our right side. So it's just sort of the same code. And we're going to do right.set speed, and we're going to do drive.feed because we're feeding the information to our drive and telling it that we moved something. Okay, now let's say that we don't want to set it individually and we want to set it all together. Now we'll make a function and we'll call this our tank drive. So public void, again, we're not returning anything. And this is going to take a left speed information and a right speed information. And this is where our drive system comes into play. So our differential drive, we can actually do drive.tankDrive, and right here we can enter in our left speed and right speed, and wow, it works, perfect. And we're just going to do drive.feed at the end to update it. Actually, we don't even have to do drive.feed because we're directly just updating that. Okay, perfect. So now we've set basically all of our code. We're just going to do one more thing, and that's going to be a stop, just for safety. And we're going to call this our stop function. You don't need any parameters, and we're just going to do drive.stopMotor. And so this is going to stop all of the motors in our drive system. Okay, perfect. So we've added all of our code, which is just a set speed for the left side, set speed for the right side, and a tank drive over here. So now our drive system is completely set. I will be going over this in person. This is just for anyone that's online, maybe just to catch you up. If you have any questions, please just let me know on the Discord. Okay, let's continue. So now I'm going to head into commands. And so in commands, I'm going to be making a new command. And I know it's like completely, I think they used to have like a pylib add command sort of thing, but they completely removed that. So really unfortunate, but whatever, we deal with it. You're going to go to this commands window over here, and you're going to make a new file. And we're going to call this our drive command.java. And make sure the capitalization is exactly as I have it set over here. Okay, perfect. So now we have our drive command over here. And so instead of doing any of that, we can actually just copy over whatever is here, because this is basically exactly what we wanted, and it's just nice, it's easy to do. So we're just going to copy this because it's an empty command, and that's exactly what we want in our drive command, and we're going to do Control-A, Control-V. And you'll notice that the first error is that our name doesn't match. So the name of the file and the name of the class actually have to match in Java. So we're just going to set this to our drive command over here. And then we're also going to have to update our constructor. And so we're going to set this to our drive command constructor over here. Okay, perfect. So now that we have everything there sort of set up and we're good to go, we're basically just going to write the rest of our code. And so the rest of our code is just going to involve what is inside of the subsystem, so what is happening on the inside, and what is inside of the command, what subsystems does it need, and how are we going to be using those. And I'll explain exactly how that works. So first we're going to need the subsystem for our drive. So what I'm going to do is I'm going to make a private drive subsystem, and then if I hover over this and I tab, it should automatically import my thing over here. If it doesn't automatically import, you're going to have to add this line yourself. Import frc.robot.subsystems drive subsystem. So we're going to import this into our code. So we're going to make a drive subsystem, and we're going to call this our drive subsystem like this. And we're just going to set it over there. And we're going to do the same thing, but this time we're going to be making an Xbox controller. So this is just how we're going to get an Xbox controller inside of our code to control the robot using our tank drive. So I'm going to tab on this again, and it should automatically import my Xbox controller. And I'm going to call this one my controller. Okay, perfect. So I've set two things up over here. Now, when we're making our new drive command, we're going to get this information. So I'm going to set these as parameters for the constructor. I'm going to make one for our drive subsystem, and this is the one that's being inputted, so I'll call it drive. And the same for the Xbox controller. This is the one that's being inputted, so I'll call it Xbox. And so what we're going to do is we're just going to assign values from those to what we have inside of our function over here. So we're going to say that drive subsystem equals drive. So we're basically just assigning it to what's been inputted. Assigning value to what's been imported. And we're going to do the same thing for Xbox. So I'm going to say controller equals Xbox. And we're just assigning what we did from before. And now what we're going to do is we're going to add a requirement. And we're going to say that this function needs the drive subsystem to work. So it needs drive, which is the one that we inputted, to work. Needs inputted drive to work. Okay, perfect. So now that we've set all that up, we'll see that this is when the command is initially scheduled. So when we first run this command, what are we supposed to do? Well, we're just driving the robot. We don't need anything specific to do here. So I'm going to pass on that. And then execute. So this happens every time the command is scheduled, or every time it's repeated. And so this is the part that's important. This is where we're going to be adding most of our code. And so what we're going to be doing is we're going to be getting the axes. So you know how in an Xbox controller you have two sort of joysticks? The axes, you have an x-axis, which is the horizontal one, and a y-axis. And the results from those are actually, very conveniently, if you go all the way up, it's going to be 1 on the y-axis, all the way down is going to be -1 on the y-axis. So we can directly patch that into our motor, or the speed of our motor. So that's exactly what we're going to do. We're going to say double left speed equals, and we're going to get it from our controller. So controller dot get y, and we're going to need to get y from a certain hand. So say hand, again you have to import this, so you're going to press tab over here, and it should add the import to the top over here. Hand, and we're going to say that this is going to be from our left hand. So our left speed comes from the y-axis of our left hand. And we're going to do the same thing for our right speed as well. I'm going to say this is controller.getY. We're going to say that the hand is the right hand. So hand.kRight. Okay, perfect. So now that we have the left and the right speeds, we're just going to set that into our drive system. So we're going to say drive subsystem.tankDrive, and we have our left speed and right speed. All right, perfect. So now it's going to assign the speeds that we get from our controller every time we repeat it. So it repeats every single nanosecond. So let's say we change it, not like every single millisecond basically. And so let's say we change it and I turn it off. Well, now it's going to update it and the speed is going to be 0, so it's going to stop. And so now, once the command ends or is interrupted, I want to stop the motors, right? Like I don't want them to continue moving. And luckily, we did write some code for that. So drive subsystem.stop. Perfect. So now we're going to stop all the motors on our thing. And returns true when the command should end. Well, we should never stop driving, so this is always going to return false. And runs when disabled, false. We should not be able to run this when the subsystem is disabled. Okay, perfect. So now what we're going to do is we're going to head over to our robot container over here. And then you'll see that we have our drive subsystem added in. Right here, mDrive subsystem, we have a sendable chooser. And for the joysticks, we're going to add our own in. So we're going to say private final Xbox controller equals new Xbox controller. And then you have to assign a port. So we're going to say it's 0. Okay, perfect. So we've created our Xbox controller alongside everything else, and you're going to see all this sort of pre-generated code, but when we're first making our robot builder over here, we want to set our default function for our thing. And so to set our default function for our drive subsystem, we're going to put it inside of this constructor over here. So I'm going to say, let's say we put it right beneath this chooser option. We're going to say drive subsystem, the lowercase one, not the uppercase one. Let's say drive subsystem, or m_drive subsystem, because that's how it makes it over here. .set default command. So this is going to set the default command, and we're going to say that this is going to be our new drive command. And so I'm going to press tab over here so that it actually imports my code, and you'll see that it'll import my drive command over here, or it imports all of my commands. So it'll automatically have it, and it should import it. Now it's going to be asking for my drive. Well, my drive is going to be my drive subsystem over here. And it's going to ask for my controller. Well, that's my Xbox controller over here. Okay, perfect. So now I've set my default command to be a drive command, which is going to drive the robot. And so now that's a default command, it's going to automatically activate. And now my robot is going to keep driving because it'll never finish. So it'll just keep driving again and again, and we've written all of our code for it. Perfect. So you should be caught up to speed, even more than up to speed, if you watch this video. Again, if you have any questions or if you want to explain it in a better way, please let me know. But there are a lot of things here that are confusing that you don't need to know about just yet, so just ignore those and just try to look through the code that I just wrote. So it's only the code that I just wrote. Okay, perfect. I hope you had a great time watching through this. I hope the audio quality wasn't that bad, and I'll catch you on the flip side. Thank you so much for watching.